Here we take the idea of multiplying two functions to a different level. We have a function y equals f of x in blue here, function y equals g of x in green here. And we want to find the graph of the product function, which is going to be this red dotted line graph here. Now how do we get this product function? First thing we need to do is determine where one function or another is 0, because that's going to give us an automatic, each 0 is going to give us an automatic point on the graph. G of x is 0 here and here. F of x is never 0. So anyhow, at least at these 2 points, the product function has to pass through the x-axis, because when we multiply 0 by f of x, we're going to get 0 no matter what f of x is. The next thing we look for are points where f of x or g of x are equal to 1. We've got the level 1 labeled on this graph and represented by the red dotted line. So this red, or I guess that's a, yeah, it's red, it should be brown I think, but this dotted line here represents the points where the value of one function or another is 1. So we see that here, for example, g of x equals 1. Okay, the green graph. If g of x equals 1, then f times g is going to just equal f. So we have a point on the graph of f right directly below where g equals 1. For the same x value that makes g 1, the product function will be equal to the f of x function. Here again we have g of x equals 1, so that we have a point on the f of x graph directly, well, for the same x, the product function will be on the f of x graph, for the same reason as before. We also have a couple of places where the f of x function is 1. It's 1 here, so that the graph point will be on the graph of the g of x function. And let's say no, f of x doesn't come back through 1. So those are the points where one function or another is 1. So now we have points here, 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 and here. Here we can see pretty much how the graph is shaping up. We also want to look at points where one function or another is negative 1. We notice that here, for example, g of x is negative 1, so that when we multiply g of x by f of x, f times g function is going to be equal to the negative of the f function. So from this point, we look up to this function, we see that the function has this value represented by this distance, and we come this same distance below the x-axis, and we get the point on the graph of the g of x function. We come down just a little bit to see that. Okay? And similarly over here, g of x is negative 1, so that the value of f of x, which here is represented by this vertical arrow, will be represented by a vertical arrow in the opposite direction, and that'll give us the value of fg, since multiplying by negative 1 reverses the sign of the function. So fg is negative f. If this is f, then this is negative f. So we have points here, 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 and here. The graph is going to apparently look pretty much like this.